In this video, we're going to take a look at the law of sines, the ambiguous case. We're going to be focusing on triangles where we're given SSA, two side lengths, and a non-included angle. If you take a look at the bottom two figures, we see that in these figures we have two sides marked as congruent and an angle marked as congruent that's not in between them. Now you'll notice that side AC and side AD are different lengths. It's possible to have up to two different triangles with SSA. In this first example, we're going to try to figure out if there are 0, 1, or 2 possible triangles with our given measurements. Remember, law of sines is all about dealing with pairs. I noticed that this 29 degrees is across from 11, and this x degrees is across from 20. So I'm going to start with the sine of 29 degrees over 11 is equal to the sine of x degrees over 20. At this point, I'm going to cross multiply, so I have 20 times the sine of 29 degrees is equal to 11 times the sine of x. I'm going to divide both sides by 11. These reduce over here, so I'm left with 20 times the sine of 29 degrees over 11 is equal to the sine of x. Now remember, we need to get x all by itself, so to undo sine, I'm going to take the sine inverse of both sides. Sine and sine inverse undo each other, and if I type all of this into my calculator, I end up with my missing measure of x is 61.8 degrees. So I'm going to go ahead and fill that into my diagram, 61.8 degrees. Now, if you remember from class, it's possible that we would have a different angle measurement, and to figure out our second option, we're going to take 180 and subtract that angle we just got, and we're left with 118.2 degrees. So I'm going to fill that in here. I checked to verify that the two angle measurements that I have are already less than 180 degrees. So now I can figure out what angle measurement would get me to 180 in both triangles. So if I take 180 in the top triangle and I subtract 29 plus 61.8, I'm left with that top angle measurement is 89.2 degrees. In the bottom triangle, I'll take 180 degrees and I'll subtract 29 plus 118.2 degrees, and I'm left with 32.8 degrees. You'll notice that in this case, there are two different possible triangles with this case of SSA. Let's try that example again. Let's see how many different triangles are possible with this version of SSA. Remember, we're dealing with pairs. This angle B is across from 16, and this 115 degree angle is across from 123. So I'll start with the sine of B over 16 is equal to the sine of 115 degrees over 123. I'll start by cross multiplying, so I have 123 times the sine of B is equal to 16 times the sine of 115 degrees. To get B all by itself, I'm going to divide both sides by 123. They'll reduce here. So I'm left with the sine of B is equal to 16 times the sine of 115 degrees over 123. Now to get B all by itself, I need to get rid of sine, so I'm going to take the sine inverse on both sides. Sine and sine inverse undo each other, and if I type this all into my calculator, I end up with my missing angle measurement is 6.8 degrees. All right, let's see if there's a second option. To find my second option, I'm going to take 180 and subtract that angle measure I just got, and I'm left with 173.2 degrees. Let's take a look at my figure. So that would mean that my 115 degree angle is here, and that new angle, 173.2 degrees, goes right here. If I take a second to look at this, I notice that 173.2 plus 115 degrees is already over 180 degrees. So there is no way that this triangle could exist in real life. So that means that I only have one possible triangle I could be talking about. I could finish this up by figuring out that last angle measurement, by taking 180 and subtracting the two angle measurements I already have, and I'm left with 58.2 degrees as that missing angle. In this last triangle, let's solve it. That means we're going to find all the possible missing sides and angles. All right, so 30 degrees is across from 10, and let's solve for angle B, and that's across from 16. I notice this triangle has SSA labeled, so I'm going to have to check to see if there's a second case or possibly 0 cases. All right, so I have the sine of the A pair, so sine of 30 degrees, over 10 is equal to the sine of B over 16. At this point, I'm going to cross multiply, so I have 10 times the sine of B is equal to 16 times the sine of 30. I'm going to divide each side by 10, which leaves me with the sine of B is equal to 16 times the sine of 30 degrees over 10. To get B all by itself, I need to take the sine inverse of both sides. Sine and sine inverse undo each other. So if I type all of this stuff into my calculator, I have my missing angle measurement is 53.1 degrees. Okay, so now let's take a look and see if there's a second option. So I'm starting with my 30-degree angle. I take 180 minus that 53.1 degrees, and I'm left with 126.9 degrees. At this point, I need to verify, make sure that the two angles add up to less than 180. We're in good shape. Okay. So I have two possible triangles. Now in each, I need to find my missing angle measurement for angle C. So in the top one, if I take 180 minus 30 minus 53.1, I'm left with a top angle of 96.9. And in the bottom triangle, if I take 180 minus 30 minus 126.9, I'm left with 23.1. All right, so we've found all of our missing angle measurements. Now, in order to solve the triangle, we need to find the missing side length in each. And let me just copy down the two original side lengths on the bottom. I'm going to label the missing side length on the top triangle as X, and the missing side on the bottom as Y. So let's go ahead. I'm going to deal with I'll deal with the A pair, and now I'll deal with the C pair. So I have the sine of 30 over 10 is equal to the sine of 96.9 over X. From here I cross multiply, so X times the sine of 30 degrees is equal to 10 times the sine of 96.9. I'll divide both sides by the sine of 30, and I have that my missing side length for X is 19.9. I'm going to do the same process again for the bottom. I need to make sure that I'm solving for Y, so I'll choose my C pair. And I can choose either, but I'll choose my A pair again. So I have the sine of 30 degrees over 10 is equal to the sine of 23.1 degrees over Y. From here I cross multiply, so Y times the sine of 30 is equal to 10 times the sine of 23.1. I'll divide both sides by the sine of 30, and I'm left with Y is 7.8. And now we have our two final triangles solved involving SSA, the ambiguous case.